it will be on BJT, yeah. Okay, anything on BJT. Mm, Kenapa unable to connect? Okay. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay. So last time we talked about the inversion layer. So we talk about the NMOS, how you will get the inversion layer. Now today, we want to see how you can get current. So these are the 3D that I was talking about before. Okay, the 3D, so it extends into. So kalau length is, can you see? The length is this from the source to the drain. What is this? What is and this? Oh, already there. This is the width. So normally when you draw a transistor, you have to draw the length and the width. The length is the technology. The length is the critical, critical size that will, if you say we are using 7 nanometer technology, it means the length is 7 nanometer. It's like it doesn't matter the width, right? So the width, you can design the width based on your simulation. Okay, so you have the length, you have the width, the oxide thickness, also important. Then you have the source, you have the drain, and you have the gate. Okay. Uh, and each transistor is isolated with another transistor with the oxide layer. So you have insulator lah in between transistors. Okay. So, okay. The current in the MOSFET. The current in the MOSFET is a result of the flow of charge in the inversion layer called the channel region. So inversion layer, so this is called the channel region, adjacent to the oxide semiconductor interface. Okay. Sometimes we call the channel length and channel width. Okay, kita tahu. This one I told you before, the back-to-back diode that we have, because we have a P and N junction over here, P and N junction here connected. So back-to-back diode. So it should be when it's at the off state, it should be really off lah. Theoretically, it should be zero current should be able to flow, but nothing is perfect in life. We learn nothing is perfect in life. Theoretically, you can this and then suddenly, wait, how come we have current? So there are things that make it suddenly you have leakage current. Okay. So when you apply a voltage, and then to create this inversion charge or this inversion channel over here, this transistor is called enhanced mode MOSFET. So one is the name, enhanced mode MOSFET. And so NMOS means N-channel MOSFET. NMOS means N-channel MOSFET, but whereby the channel is made of N, meaning electron. If it's PMOS, it will be P channel, which is the channel is due to the hole. Okay, so I'm just recapping from last time. So threshold voltage, we talk about threshold voltage is the minimum voltage, right? Is defined as the applied gate voltage needed to create an inversion charge or inversion channel. So the minimum voltage to create this channel beneath the gate. If the gate voltage is less than the threshold voltage, then you won't get any current because there's no channel, there's no like a bridge to connect between the source and the drain, so that they can be back to back diode tadi kan, so nothing can flow. So you need to have a channel, a bridge here to connect the source to the drain, because the source is N type, the drain is here is N type, and now you're making like connecting it, and then it becomes N juga tengah-tengah ni. Okay. Okay. Now, all right. So let's go to my. All right. This is what we. This is what we talked last time regarding the how you get the how you get the inversion channel by applying a gate voltage which is greater than threshold. Now previously we make the source and the drain to have zero voltage. You don't connect it anywhere. So in order for you to have current, you need to connect the source and drain to a voltage to bias it. So okay. So now let's apply. Normally the source you apa nama ni? You ground the source and you apply a voltage to the drain. Okay, you apply the voltage to the drain. So the drain voltage, because this is an NMOS, so you apply a positive voltage. Why? Anybody can guess why we apply a positive voltage to the drain?
Because we want the electrons to run from source to drain.
Because yes, you want to attract the electron, right? You want it to be so you put the positive voltage to attract the source, the current, the electron to go to the drain. So this is the inversion channel. So now the electron. So now you are completing the circuit. Previously there's no voltage. It's not complete the circuit. Now we have a circuit out there, so you can have so now the electron can move from the source to the emission channel to the drain and going out, right? What is the direction of the current? What is the direction of the current here? Kat sini. Is it going up or going down?
Going down.
Why?
Because current is the opposite of electron flow.
Good. So it means that the direction of the current is downwards. This is ID, the one that you normally calculate in your first year, right? The drain current. Yeah, so it's the current is in the opposite direction of the flow of electrons. So that's the direction of the current. So that then now good. So you have now you have current, drain current inside the structure or inside the device. What is the source current? What is the source current? What's the value for the source current? Anybody?
It should be the same, right, as ID.
Yes, good. That's a trick question. Yes, the source current is the same as the drain current because this is one channel. There's a two line the phone is in series. So ID equals to IS. Sebab tu bila I remember, I don't know whether you remember in your first year when you do electronics, you belajar ID equals IS. I don't know whether you understand or not at that time. Masa tu banyaknya hafal kan, kita hafal. So because I 2 ke 3 tahun lepas saya teach electronic, dah 3 tahun kot saya tak mengajar electronics first year. That's why I think I never met all of you. So biasanya saya akan jumpa student first year. ajar electronics. Tapi sekarang ni dah sibuk. Banyak ajar subjek lain. So tak ajar dah electronics. Okay. And when I teach electronics, my favorite part is when talking about the physics. Calculation tak minat sangat. Alright, so now we understand how it works. So now what is the condition? So dia ada beberapa condition for ni for MOSFET kan. Kita ada saturation mode. Apa lagi mode yang ada?
Linear mode and cut off.
Linear mode and satu lagi cut off mode. So what's the difference of the three with this diagram here? Where's the difference?
The channel.
Okay. Okay. Padam kita draw baru lah. So you need to know how to draw this diagram, the 2D diagram. Yeah, you know, many students, I keep on repeating this every semester, and interestingly, every semester ada je student buat mistake ni. Saya pun tak faham lah kan. You know, when they draw this, you know what's the mistake? They omit the oxide layer. Dia draw macam ni. Macam ni je. Then of course lah, salah. Dapat 0 straight away. Mana the MOSFET will not work without the oxide layer. So you need to have the nama dia pun MOSFET lah, metal oxide semiconductor. So you have the gate, you have the oxide, and this is your MOSFET. So in cut-off mode, what is the condition for it to be in cut-off mode? Anybody? You can Google. If you don't remember, what is the condition for it? You understand beside the condition. Condition means what voltage, because the device is device change je lah. So in between the three modes, the only difference is you play with the voltages, the biasing of the gates, of the terminals. So cut-off mode, what's the condition?
VGS equal to 0.
VGS equals to 0. Betul ke?
VGS is lower than threshold voltage.
That is more accurate. The VGS 0, yes, it will be in cut-off mode, but kalau VGS ada voltage pun, which is not 0, if it's less than the threshold voltage, it will still be in the cut-off mode. Cut-off mode means there's no current. So cut-off mode means ID equals to 0. So when ID equals to 0, it means there's no inversion channel. You cannot, even if you put the drain voltage VD ni to be very high, tapi tak ada inversion channel, nothing will flow because there's no connection between the source and the drain, right? So the number one you should establish is the inversion channel. So the VGS less than VTH or VT. Okay, so this is let's call this NMOS. Okay, so this is an NMOS. So whenever you have that, the inversion, there's no inversion channel, so therefore there's no current. Okay, next mode. What's the second mode?
Linear mode.
Okay, linear mode. What is the condition?
The condition is VGS it must be larger than threshold voltage, but the VDS is smaller or equals to VGS minus VT.
So this is the second in linear mode. What does a linear mode means? The one that we talked just now, this one, where the channel is linear. dia straight je macam ni, right? That's the linear mode. Okay, when you get enough and everything are normal, so mean that the VDS is less than VGS minus VT, then you will get, I won't draw you. This is the what happens. This figure is what happens when it's in linear mode. So if we look at in the graph, the graph of the apa namanya, ID versus VDS. Yeah. Okay, so if we tak dekat yang sebelum tu. Sini je lah. So this is the drain current versus VDS, right? This is a normal characteristic of a MOSFET. So if they ask you in any interview, right, draw the characteristics, the current characteristics of a MOSFET, you will draw the drain current versus VDS. And at when VDS is less than VGS minus VT, which is this point, you can see the current are linear. So as you increase the VDS, the current will increase linearly, right? Assuming the source, we make it 0, so we can simplify this in VD. As you increase the amount of VD, the drain current will keep on increasing until it reached to a point where it will saturate like this, right? And this is in the saturation mode. So going back to our drawings now. So it means that here, let's say if I keep on increasing I increase. So if I keep on increasing, for example, I put 2 volt. Okay. What happens when I put 2 volt? And then what happens if so now I have so let's say VT is 0.7, I'm apply a VG and I ground the source, I apply VG to be like 1 volt. Okay. And then I apply 2 volts at the drain. Next, I apply 4 volt. VGS minus, so VGS minus VT equals to adalah 1 tolak 0.7 0.3. So I'll make it bigger. So let's say I make the voltage here bigger. So I make the voltage here to be 4 volt. So 4 minus 0.7, it will be berapa? 3.3 terang.
Yes.
So 3.3 volt. So now if I apply this voltage of 2 volt, okay, saya tukar ni. I apply a 1 volt voltage. This is case A, and then I apply a 3 volt. Okay, what's the difference between what happens inside the MOSFET when I apply a 1 volt and 3 volt? Can anybody tell me? What's the difference? Is there any difference?
Yes. The channel size.
The channel size, but I keep the VG constant at 4 volt. My gate voltage is constant at 4 volt. Okay, I will ask another question later. Kita buat ini dulu. Sebab you trigger me to ask another question. Okay, so now I make the gate voltage apa nama ni constant of 4 volt. I just change the drain voltage. What will happen? Rasa-rasa ni lah. Zarif, what do you think?
Hello, pinch off.
Pinch off,
Hmm.
right? What is pinch off? Awak membuka, Pandora's box, Pandora's box ni. Awak buka tu macam in the end banyak soalan-soalan yang akan saya tanya. Apa tu yang awak kata tadi apa nak? Punch apa tadi?
Pinch off.
Pinch off. Apa tu pinch off? Zarif?
Apa tu?
S the drain voltage.
S yang drain voltage. Apa nak cakap? Bila drain voltage dia bertambah, perbezaan apa? The difference in voltage between the drain and the gate will become smaller. So at certain point tu the difference akan jadi makin terlalu kecil untuk maintain the channel, to maintain the channel. Pinch off.
Okay, kita tanya orang lain, agree ke tak? I like to play this game. Tanya Hazim lah. Hazim, do you agree with Zarif?
I actually don't understand what pitch off is, so I cannot say.
You agree. So then I ask you what happens now. If you don't know, then now I change. I make the gate voltage the same. I change the drain voltage from 1 to 3 volt. What happens inside the MOSFET? Hazim. Do you think there's any difference or no?
I think there is difference.
What do you think? Logically lah.
Should we?
Siapa nak bantu? Yes, pick your brain in the morning. Because the lessons, when I was learning, I wasn't told to be spoon fed. Saya tak diajar untuk spoon fed lah. Bila kat YouTube tu dia tak feeding sangat. Malaysia feeding. Lepas tu saya macam terpobok nak suruh fikir. Sana tu tak tu nak suruh fikir. Siapa nak bantu?
I can try.
Yep.
So, yes. So, in my opinion, when you increase the voltage, the channel would be, the more electrons would be attracted until because when we supply the VGS at 4 volt, whenever we supply from 1 to 3 volt, the channel size would be increases as more electrons would be attracted to the channel. But when we reach more than 3 volt, then since there is a limit how many electrons that could be attracted by the channel, So
It's 1 to 3. Don't talk. That's not this. And
sorry.
we are discussing 1 and 3. Let's not discuss more than 3 because that will be another answer. Let's
Okay. So the channel would become thicker and thicker.
thicker and thicker. All right. Thank you. Do you agree? Kita dah bincang. So hopefully from your the previous understanding, you should be able to think. Saya takkan tanya soalan kalau tak boleh fikir. Do you agree with it, Nabiha?
When voltage increase, I think the current increase as well.
Yes. So what happens inside the MOSFET?
More electron
More electron what? Huh?
in the channel.
More electron in the channel. So do you agree or not with Afiq saying the channel will become bigger?
I agree.
Oh, you agree. Okay. So ada seorang ada penyokong. Kita tengok lagi. Ada lagi penyokong ke tak? Nick.
I want to change my answer.
So Nabiha, your boss want to change. Apa Afiq?
So the channel will be the same, but the electron density that will pass through will be higher.
Okay. So now you're saying the
Yes, because the amount of electrons being attracted, which makes the channel would remain the same.
okay, now the new answer by Afiq is the channel remains, the thickness of the channel remains the same, but the number of electrons flowing per unit time increases. Betul Afiq? You agree?
Yeah.
Okay.
Yes. I think that's.
Okay. Tanya Anas. Awak setuju ke? Ke macam mana kita ni?
I agree, madam, with Hafiq on that one.
Why you agree? Why is the channel not increasing?
Because we do not tamper with the gate voltage. We only tamper with the drain. So only the electrons through the channel F and D channel are moving, not in the P type. That's what I think.
Not in the P-type?
And not in the body, not the electrons in the apa nama dah? Inversion layer.
Can you repeat again your answer?
Because we only changing the voltage in the drain, so we do not tamper with gate voltage, so the thickness of the inversion layer does not change.
Hazim, betul ke? Oh, saya tak jawab. Saya tanya awak. You agree? Hazim?
I agree with the part that when Afiq says that the channel doesn't change.
Okay. So good. So sekarang kita kelas yang lepas kita cerita macam mana kita dapat inversion channel tu. Kita dapat inversion channel due to the gate voltage. So if I don't change the gate voltage, how come the thickness of the inversion channel will be different, right? Because it depends on the thickness of the inversion channel, depends on the strength of the electric field, the attracting number of free holes. Free electron over there. So lagi besar the voltage, there will be more electron that be accumulating to make the inversion channel. So now, so that's why. But now we change the drain current. Dia macam saya selalu cerita ke student kelas saya bagi analogi. Dia macam the drain voltage. It's like if you increase the drain voltage, it's like you are pressing. Apa nak bawa kereta kan? Bawa kereta, semua ada lesen ke? Kereta orang tak ada lesen. So ada lesen, kalau tekan apa nama ni? Pedal minyak tu. Kita panggil apa pedal bahasa Melayu? Kan apa? Apa benda? Yang Melayu tu panggil apa? Pedal minyak tu panggil apa? Pedal tu apa Melayu?
Pedal. Bahasa Melayu pedal.
Ada juga.
Hmm.
Ya.
Pendikit.
Apa? Okay. So I was okay every time I went to a public talk. Kalau dengan orang awam, I will do a disclaimer first. Saya akan kata saya minta maaf, saya akan bercakap ni mungkin bercampur English sebab saya punya full in Malay is actually very bad. Sebab sejak balik ke UK, saya work in a company yang cakap semua English. Lepas tu saya duduk kat UIA pula yang semua English. So my Malay public speaking is actually not very good. And if I speak Malay, I will speak Terengganu punya Melayu. Saya tak boleh cakap KL ke Bandar ke, tak boleh, saya dekat keluar Terengganu lah. So and sometimes I cannot find the word. So brain kita dah boleh cakap, pegang je mic English. So jadi susah sebenarnya nak kena train. Tapi it's good sebenarnya kalau boleh cakap Melayu dengan saya tengah train dah diri saya cakap Melayu. Okay, so pedal lah, the minyak punya ni, dia macam kalau kita bawa kereta kita tekan minyak. Maknanya bila kita increase the voltage, kita tekan minyak, so more bila kita, elektron tu akan pergi lagi laju. Okay, so that's why if you see the ID versus VDS, as you increase the drain or VDS, it will keep on increasing sebab kita just push elektron tu pergi laju lagi, flow per unit time. So semakin banyak. The channel remains the same. Then my next question is, now since awak tu patut boleh jawab lah ni. If you understand konsep dia tadi. Alamak, dia dah hang. Okay. Saya tak faham lah kenapa dia ada hang sekejap. Saya unshare first. Sometimes dia hang. Tapi Alhamdulillah, thanks to this technology I can write. Imagine kalau saya mengajar. Can you imagine saya mengajar semiconductor ni, saya tak boleh draw. Tengok PowerPoint saya mesti tak tahu lah faham ke tak in the end. So Alhamdulillah, we have a technology in the end. I can draw. Okay, now I change. Now I change. I make the drain voltage remain constant at 3 volt. But now I change the gate voltage from 2 to 4 volt. What will happen? Ini saya nak tanya, jangan jawab lagi. Kita tanya Mirza. What do you think? Mirza, you there?
Mirza mana Adam?
Oh, ada 2 Mirza. Ada 2 Mirza. Okay. The brother. Mirza brother.
Apa soalan dia tadi? Adam?
Ya, kenapa tak dengar soalan saya? Buat apa?
Saya bising sekarang Adam.
Apa?
Ada orang tepuk dinding. Kabel saya bising, ada orang tepuk dinding.
Kelas.
Betul Adam, serius.
Saya tapi saya just kata sekarang saya mengajar awam nak apa mesej pula masa kelas. Okay. So my question to you, listen. Now I change the condition. I make the drain voltage to be constant at 3 volts, and I change the gate voltage from 2 to 4 volt. What is the difference in the MOSFET? Dengar.
Dia punya apa? Dia punya apa nama? Ya Allah lupa. Inversion channel dia tu dia akan lagi tebal. Lepas tu current dia lagi banyak. Hello?
Hello, speak in English.
Oh, okay. So when increase the gate voltage, decrease the gate voltage, the size of the inversion channel will become lesser because low electron attracted to the to that side.
Less number of
Less. Yes, less number of electron, and the number of current also will become less. Will remain lah because remain kan 3 volt kan.
Thank you.
Macam
mana awak kata the current will be the same?
lain lah.
So how about the current? Is it the same? Amiza?
So same kan? Because
So you say the same,
same ke?
Okay, thank you. Mirza sister, you agree or not with the Mirza brother? Boleh ke tanya soalan tu? My sister.
Not madam.
Huh?
Not. Madam ni ada?
Apa? Kenapa gelap betul tempat awak tu?
Kamera ni memang macam ni.
So do you agree tak dengan Mirza Ashraf?
No.
Why not?
For the invasion channel, I think it will be thicker.
Macam mana?
For the invasion channel, I think it will be thicker.
When what?
When the VGS is increased. From 2 volt to 4 volt, right?
Did you say, I wonder, awak dengar tak Mirza jawab tadi tu?
Dia 2 volt ke 4 volt ke?
You can either say 2 volt to 4 volt or 4 volt to 2 volt. It depends how you. So jadi,
Okay.
so Mirza jawab sekali lagi. Mirza apa ni brother, Mirza sister listen lah, and the rest of you listen.
Okay. Okay, so when we increase the voltage at gate from 4 volt to 2 volt, the size of inversion channel will become smaller due to the
Mirza tunggu. After you increase
decrease.
Decrease.
Apa? Increase? Saya cakap decrease.
Oh, kita dengar increase. Sekali lagi.
Okay. So when we increase the voltage at gate, so the inversion channel will become thicker lah because it will attract more electrons to that side. So the electron increase, the inversion channel will become thicker. And then if we remain the voltage is remain, right, madam? 3 volt. So
which voltage?
At drain.
Okay, kena bikin spesifik. Awak tanya voltage mana? Source, drain, gate. Okay, so the
voltage drain
remain the same, yeah.
It remains. So there is no change in current, I think.
Okay.
There's only change in inversion channel.
Okay, Mirza, do you agree with Mirza Azhar? Do you agree with the brother?
For the inversion channel, yes. For the current, I don't think so.
Why not? What's your answer?
The current flow increase.
Tak dengar.
Current, there are more electrons.
So what happens to the current?
Increase.
So Mirza Azhar answering the current will increase. The cross check dengan Azimuddin pula. What do you think?
When the gate current gate voltage increase, the inversion electron inversion channel will tebal apa? Thicker. So more electron so when more electron in the inversion channel, the drain voltage is higher.
Drain voltage.
Drain current, sorry.
Higher. Oh, jangan buat silap macam tu. Then voltage current kalau silap, dosa besar tau. Sebab you ada sebab tak tahu nak bezakan. Okay. So can you say in one sentence about the current? So you agree tak? Which one you agree? You agree dengan Mirza Azhar ke Mirza Ashraf? Tak agree dua-dua?
I think Mirza Azhar.
So you are saying the current will increase because?
Yes. More concentration of electron.
More concentration.
More electron.
Yeah. More concentration dengan more electron tu pun maksud lain betul tak?
Yes.
Alright, so that's why I said semiconductor ni awak kena careful lah kalau tulis apa-apa sebab dia boleh maksud dia lain. Dia very sensitive to terminology. Okay, so the answer is yes. If you increase this what do you call it, the gate voltage. Allah, they hang lagi. I don't know why they hang. See, dia hang. Saya kena tutup dia. So bila every time dia macam apa? What do you call it? Dia screen saver tu. Dia jadi hang. Oh, I know. Cakap tu biar dia. Okay. So whenever you increase the gate voltage, what happen is you applying more electric field, MOSFET field effect transistor. So if you increase more of the voltage at the gate, that means that you have a bigger, you are attracting more minority carrier towards the surface between the oxide and the semiconductor. Therefore, you have a bigger a thicker inversion channel. So kalau 2 volt, let's say kalau saya draw, this is 2 volt, 4 volt saya buat color kuning. So kalau 4 volt ni color kuning, so the 4 volt will be here, right? So the thickness of the inversion channel will be the yellow line over here. It just become thicker and thicker and thicker. So in terms of the current, yes, the current will increase. So how do we know? If you do experimentally, let's look at the slide again. Ada ke graph yang let's see, ada ke? Tak pasti dalam slide saya ni ada ke tak. Ni yang kita change the gate VGS. Okay, see here. So this can you see here, ni a graph of ID versus VDS, right? So and this is for different VGS. Okay, so as you increase the VGS, you can see per given, kalau kita ambil sama point, the VDS is the same. So the current is different. As you increase the VGS, the current will also increase because it makes the inversion channel bigger. Hence, kalau macam awak bawa kereta kan, so macam daripada 1 lane kepada 3 lane, right? It's easier. Then number one, first easier, but the number of free carriers inside the inversion channel is also increased. So you can get more current. So there are 2 ways of making to increase the current. Number one, you can increase it by increasing the drain voltage. Number 2, you can increase the current by playing with the gate voltage. Okay. Now, so that's in linear mode. Now, what happens if kita tukar silap. Okay, what happens if we okay, now we assume the threshold voltage to be 0.7, and now let's apply a voltage of so we still apply this as 4 volt. Now, but the drain voltage now kita apply 5 volt. 5 volts. Okay, what happens inside the MOSFET? So now which is now we are entering the saturation mode. What's the condition for saturation mode? You still need the channel, because saturation mode means you still have current. So it means that there must be a inversion channel. So VGS should be greater than VT, and then so the VDS should be greater than VGS minus VT. Okay, so if I calculate correctly, my V set is 3.3. Now I'm applying a 5 volt, right, to my to this transistor. What happens inside the transistor now? Who wants to answer? Muhaimin lah pula. Tak dengar suara Muhaimin lagi ni. Kenapa tak ada video Muhaimin?
Saya Zoom tadi lag.
Oh, okay. So Muhaimin, answer this. So what happens if I make the VD to be now what happens when I apply VD is 5 volt to the my MOSFET?
Just like what Zarif already said. When we apply a higher VDS, there will be a pinch off occur. So there is no further increase in the drain current.
What is pinch off?
Pinch off is that dia macam from the channel inversion channel low, and then suddenly at the one end it become a smaller just like a triangle.
Why it becomes like that?
Because sebab dia the reason I don't remember.
The reason shooting.
Apa sebab apa bila kita itu.
Siapa nak bantu?
The inversion layer becomes a triangle ke? Apa?
Yes. Why is it become like a triangle? Or can it be like this? That one satu merah. It be like this.
The electrons are attracted to the drain, maybe. In the electrons in the inversion channel.
Memang kalau yang linear mode pun electrons attracted to the drain. Sebab tu kita dapat current.
Ya, tapi this one it's because the drain punya voltage is higher than the gate. Therefore, the inversion channel isn't even.
So why do you still have current?
Because it's
why do you still have current? Boleh tak jadi inversion channel jadi macam ni, yang merah?
No.
Cannot.
Because there's still current.
Madam.
Yeah.
Because there is a what they call voltage drop. Voltage drop between the VDS and the VGS.
Faham ke Haris? Muhaimin punya jawapan?
Ya, tak.
Muhaimin, tak faham lah.
So as the VDS increases, as the VDS increase, there will be a voltage drop because benda tu. VGD equal to VDS minus VGS.
Okay. Jadi, still I don't understand. Tahu, ada orang faham ke?
Faham je lah.
I don't know if I don't understand,
Okay, Afiq pun tak faham.
but I got another point of view.
Okay, Afiq, you can.
So I think the answer relies on the diode, the back-to-back diode, in which on the VDS side is it's a reverse bias diode. It's a reverse bias since we are applying a positive voltage. On the D, since it's an NP, the higher voltage that we supply, actually it would increase the depletion layer, so in which would cause the pinch off voltage, since the electron would not be attracted at the neutral region. I think that's
Okay, that's the answer of Afiq. So kita nak faham yang Muhaimin ke Afiq ke macam mana ke? Kita ada jawapan lain. Ni. Sorry lah saya buka tutup ni sebab dia hang. So ni. Enlighten us. Ni, are you there?
Yes, I am here.
Jadi, mana? What do you think? Ni janganlah senyap.
I don't have any idea, bro.
No idea? So you don't know which one is correct? You don't. What's your opinion on the? Apa faham tak Muhaimin cerita apa?
I mean, tak jelas sangat.
Afiq, do you faham Afiq cerita apa?
Afiq lagi tak faham.
Okay, tanya soalan kepada Afiq dan Muhaimin. Ask question. So tak faham kan?
Muhaimin, can you explain the pinch off? I does not get it.
So as the VDS increases, there will be a drop across the gate outside at the drain side because the VGD equal to VDS minus VGS. That's why there will be a pinch off.
You understand? Ni.
What VGD? What just now?
VGD equal to VDS minus VGS.
Okay.
So, ni tanya soalan sampai awak faham. Kita tak habis kelas ni kalau awak tak faham.
Afiq, can you explain your concept just now? It's too fast. I cannot understand very well.
Oh, can I share my screen?
Okay, sure. Stop sharing.
I cannot. Host disable participant screen sharing.
Okay. Semua tak boleh nama untuk dekat chat.
So I think so. Basically, what I was trying to say that we have a channel already. What the saturation what happened on saturation, why the pinch off is coming in, is because of the when you increase the VD here, and then the depletion region here would be larger and larger because it's reverse bias. And since this side is forward bias, it's the size would almost the same. But when we increase here, this side, the depletion region would increase more and more. So the shape, when we increase the VD, it will become as we increase it, it become a more pinch and pinch as we increase the voltage because of the depletion region. Since there is since the depletion region is higher on this side, the electron is more attracted towards this part compared to this side. That's my explanation.
Okay, thank you. Afiq, do you understand me?
Yes.
So, which one is the answer? What do you think? Which one do you think the answer? When I put the voltage of VD to be 5 volts and the gate voltage to be 4, what happens next?
I think I agree with Afiq.
Why?
Because when VD is increased, so more depletion region, thus make the inversion channel push off, something like that.
Something like that. Okay. All right. So actually, the Mohammed, your explanation is not wrong, but it's difficult to understand. Okay, Mohammed. So, but your explanation need to be extended a bit more. So I think the easier to understand is how Afiq was saying. So basically, remember we talked before whereby there's always this PN junction, this diode over here and over here, right? So and then when we as we make the VD or VDS greater and greater, what happens is, can you see this, the P is over this side and it's over this side, right? And in order for the diode to be forward bias, which means that there'll be current. So when you need to forward bias the diode. But as you make the VD more and more larger, so the voltage at the end is higher than the voltage at the P side here. So you're getting less and less forward bias, and in the end, it will turn into reverse biasing the diode. When you start reversing the diode, then you are in between the end, the drain and the body over here, you will have a depletion region. Okay, and as you increase the drain voltage, the depletion region will be bigger and bigger. And do you have any free carriers in depletion region, Nick? Do you have any free carriers in depletion region?
No.
Okay, great. No, you cannot have. Nama dia pun depletion region, depleted. It's depleted of any free carriers. In the end, dia ada ionized atom dia kan. So there's no. So what is inversion channel? Inversion channel is like a channel full of free carriers. Okay, so kalau dalam depletion, kalau that region become depleted, so become depletion region, it means that there's no free carriers there. So meaning you cannot have inversion channel when the diode here is reverse bias. So okay, now you understand, right? So why then as you increase the drain voltage becomes pinch off, because more and more of the because as you can see here, the gate voltage, the closest is here. That's why dia jadi macam triangle ni. Sebab yang ni paling dekat dengan gate voltage ni. So yang kat sini yang akan dapat more attraction of electron. Here kat tempat ni, this area here, which is no longer inversion channel because it's far away, is even further from the gate. So kat situ lagi senang to be depleted. To the extent of keep on increasing lagi drain voltage, dia akan jadi yang macam merah ni. If you keep on increasing the drain voltage, you go like this. Then my next question. And if you finish our next question, finish lah semiconductor device course. My next question is, tak tahu siapa. Anas. Now, okay, we understand, we assume, I understand that if we increase the drain voltage, we will get this pinch off, whereby it can becomes like situation line A ni, yang apa line biru ni, and situation B, line merah, right? So it bergantung kepada how big is the drain voltage and how big is the depletion region in between. Now my question to Anas, so in A and B, in situation A and B, do we still have current in both situation A and B? Anas?
Yes, madam.
Okay, good. Then my next question, why do we still have current?
In what I Google, the current is caused by the field effect from, because the because it is caused by the field effect from the inversion region to the drain. It becomes like a drift current. That's what I think.
Drift current macam mana pula? Okay. But there's no channel. How is it possible? And why is it saturating? Why it doesn't change? Right, saturation current dia macam constant lah, lebih kurang lah. Increase lagi VD pun, maknanya dalam A ke B ke, connection A or B, the current is the same. Why? Or roughly the same. Siapa nak try?
The current stays the same because it's dependent on the field effect, which is the voltage on VGD, the voltage on VG.
How is it possible? I don't get you.
Because it's because the current is because the current because the field effect makes the current, not the current itself. So
macam mana field effect to make the current?
Yeah.
Anybody else? Okay. Since we have 10 minutes left, mesti hang lagi. Dia tadi dah screen saver. See, dia tak boleh masuk screen saver mode. Masuk je dia hang. So I give an easy analogy. Okay, how is it possible? Remember I told you it's like driving a car, right? And then so why is it saturated? Can you imagine driving in the highway from 3 lanes, it becomes 1 lane. what will happen?
Traffic jam.
Traffic jam, and there's bottleneck at the one lane tu kan. So in the end, you will travel, tapi in the end, the one that determines the speed of the traffic is the one lane yang hujung kat bottleneck dia tu. So similar to this. So for example here, why the current doesn't change? Number one is at this side. So from like 5 lane, it becomes 1 lane. So it becomes saturated. There's only a certain number of free carriers that can move per unit time. So how many cars, although you press the the minyak pedal, only certain number of carriers can move. So that's why it's saturated to one when it's still, but that is when you still have the emission channel, but it's pinch off like that. Now in situation B, where you no longer have a bridge, okay? Previously there's a bridge, right? There's emission channel connecting the source and the drain. Now in B, the electron can, if you think about it, electron pergi sini sampai kat sini, dan suddenly dia dekat sini. Masa kecil-kecil dulu, aku pernah tengok tak cerita yang, sekarang ni saya tak tahu ada ke tak. Yang apa nama ni, yang macam dia ada dua tinggi, orang naik motosikal tu kan, dia tak kereta-kereta kat tengah tu, lepas tu motosikal tu terbang pergi di other side. Yang macam dalam stadium. So dia ada motorbike yang laju, lepas tu dia ada macam ramp macam ni. So motor tu akan jalan kat sini, lepas tu sini tak ada apa-apa, dia akan terbang jatuh kat the other side. Do you get? Faham tak saya cakap ni?
Stun
Macam stun tu kan. So dia tak ada bridge kan, dia tak ada apa, tapi dia sampai kan, motor tu sampai di other side. Kenapa?
Speed, madam.
Dia dah ada
dia laju.
Momentum.
Dia laju. Remember, bila kita tinggikan BD, semacam kita tekan minyak kan. Remember?
Yes.
Sekarang ni, bila you keep on increasing BD, although the effect is in the end, you will have this bigger depletion region, but satu lagi, you still increase the field effect. You still the carriers are still being attracted very strongly, therefore the electrons are flowing fast. So the electron have the ability to jump from this emission channel to the source, to the drain, sorry. So tapi hanya ada limited lah, not all electron will have that capacity to go from the emission channel to the drain. Okay, so that's why you still have current. So I'm not sure, nanti saya check I'm not sure whether it's called tunneling or apa dia punya physics punya terminology. But basically the electrons are traveling very fast and able to go through the depletion region yang tak ada emission channel, tapi hanya a certain number of carriers yang boleh pergi. That's why it's saturated. Tak semua motor are brave enough. Kalau bagi saya pun, saya tak nak terkejut lah. Dia ada saya buat laju pun lah. Tapi maknanya elektron ni tu macam tu lah. The probability is only a certain number are able to jump from the emission channel to the drain. Therefore, you still have current. Okay, any question?
So the electron at the B region is moved to the drain because the drain voltage.
Yes. Because of the field, when we increase, dia jadi macam atas kan, kat gate ke semiconductor, you ada conductor, insulator, semiconductor, right? Tak? So ni dia jadi macam tu juga, dia jadi macam conductor, semiconductor tu lah, drain, and then insulator, depletion region, like an insulator, because you don't have any free carriers there. And then you have again the semiconductor, the emission channel. So there's a field effect again, that's satu tempat ni. So this, but because of the gate drain voltage is very strong, in the end this the electron are able to pass, to go through to the drain side. Dia ada another electric field kat situ. Okay, any more? Tapi dia depletion region ni taklah dia punya insulator tu tak seteruk apa nama ni, the oxide layer. Oxide layer memang you can it's like the the band gap is very big. Tapi depletion region you can still tunnel or go through. Dia tak sebesar band gap dia as insulator tu. Tapi konsep dia sama. Okay, ada soalan lagi?
Madam, so from what I understand, the movement of the electrons is not caused by the field effect, but the apa tadi? Field effect. What was again? You mentioned field effect just now. I didn't catch that.
Okay, dia ada dua field effect ni sekarang ni. Satu, MOSFET, metal oxide semiconductor field effect transistor is due to the field effect of the gate through the insulator, which is the oxide layer, to the semiconductor. We understand like that. But I'm telling you, when we have this, the drain voltage is greater than the VGS minus VT, in the end you have depletion region. As you increase the VD, the depletion region become bigger and bigger. Therefore, you are like, depletion region is like is a region where there's no free carriers. So dia macam insulator. Dia macam insulator tapi band gap dia tak sebesar macam normal insulator. So it means that there's another if you voltage dekat D tu dengan semiconductor at the inversion channel tu, dia macam ada another memang dia ada field effect sekali lagi. But now due to the drain voltage. So what happens is if you make the drain voltage very high, these electrons will be attracted to go to the drain and therefore dia macam jumping. Dia boleh go through lah. They can still jump across the depletion region. Tapi not many carriers can do it. The probability for the carriers to do it is not many. Sebab tu jadi saturated. Dia tak jadi keep on increasing lagi banyak, tak, dia sama je. Okay. Any more question? No?
Last, madam. Does the drain and source interchangeable?
Does what?
Drain and source, is it interchangeable?
Drain and source. Good question. What do you think?
It depends on the material, material for the drain and the source. If it's the same, maybe can.
Do we normally make different material for the drain and the source?
No, we use the same material, so it's interchangeable. It depends on the way that you supply the voltage. It will become either D or S.
The drain and source normally is from the same material. Kalau tidak jenuh kita nak kena, memang tak boleh buat lah. So normally the transistor is from one material, so it's interchangeable. So saya boleh tukar yang awak nak draw sebelah sana tu drain sebelah sini, source pun boleh. Okay, Anas. Alright. Any more question before we end? Alright, kalau tak ada soalan, alhamdulillah. So basically MOSFET will end here. Okay, I won't go through the secondary effects of MOSFET. As I mentioned, the energy band diagram of MOSFET will not go through. A bit complicated. So jadi kita stop kat sini. As long as you know, you understand how a MOSFET works, right, and how to control it. So tu bolehlah basic for you to move on kalau nak kerja nanti. So and next week, since we finish our course, alhamdulillah. Next week, I will give the Tuesday. I will give your quiz. Okay. Then after that, you have free time lah to study for your final. Okay. You can ask me questions before the final. Apa soalan kan? Jangan tunggu last minute sangat. Kalau saya sibuk last minute, I will just ignore you. So try to study earlier lah. Okay, good. Thank you very much. Can we end the class with the doa? One person to make the doa. Daripada awal kelas sampailah habis semester. Payah nak cari yang tukang baca doa.
Amin, madam.
Okay, silakan.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya wa mursalin wa ala alihi washabihi ajmain. Allahumma ahyina bil iman wa amitna bil iman wa adkhilna jannata ma'al iman. Allahumma ighfir lana dzunubana wa liwalidayna warhamhuma kama rabbayana shaghira. Allahumma akhtim lana bi husnil khatimah wa la takhtim alaina bis su'il khatimah. Rabbana la tuzigh qulubana ba'da idh hadaitana wa hab lana min ladunka rahmah innaka antal wahhab. Rabbana atina fid dunya hasanah wa fil akhirati hasanatan wa qina azabannar. Sallallahu ala sayyidina Muhammadin wa ala alihi wa sahbihi wa baraka wa sallam. Alhamdulillahi rabbil alamin.
Okay, thank you very much everybody. See you.
Thank you, madam.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, madam.
Thank you, madam.